Hello, my name is Ryan Mermel from CIMCO Software. In today's tech tip video, we're going to be reviewing the Cimco Probing module for Mastercam and show you how quickly and easy it is to program your machine tool touch probes. Let's get started. Cimco Probing is seamlessly integrated within the Mastercam interface, making programming your touch probe routines a natural part of the programming process for milling, turning, and mill turn applications. Typical brands include Remachining, Bloom, Marpos, Heidenhain, and Siemens. However, using Cimco's custom cycle builder allows you to virtually program any probe. When we select on the Cimco Probing icon in the software, you will find workpiece alignment, workpiece datum, workpiece inspection, and probe detection. Workpiece alignment will allow you to adjust any rotary axes so the part will be flat and square to the machine environment. Workpiece datum will allow you to set a work offset on your part. Workpiece inspection allows you to program your probe either in process or post machining. This includes if-then conditions for remachining and general tolerance checks. All cycles will allow you to report probing results or copy results into custom user-defined variables. Probe detection uses the probe's protected safety moves to check if a part is present or in the correct orientation, or if clamps have been removed and if the previous cutting operations have been successfully completed. In order to set a work offset on my part, I will first go into workpiece datum and select the appropriate probe cycle. In this case, I will set my Z, then X and Y. I will select the 0.1 axis and choose my probe. From here, I can go to the Cycle tab, right-click in the Geometry section, and select on an appropriate point. From there, I can change my settings and put in a measuring height, safety or standoff distance, and a clearance height. I can then also give it an over travel distance and tell it what work offset on the machine I will be updating. From there, I can go ahead and green check out and create another probe cycle for my X and Y axis using the rectangle outside cycle. The workflow will be identical by selecting our probe, going to the Cycle tab, and right-clicking. From here, we can associate two different geometry. I will choose the From Stock option, and I can again put in my relevant information for measuring height, standoff distance, and over travel. Once I green check out, I will have two operations within the Mastercam interface. I can then select both of those and run them through backplot, verify, or machine simulation to show the movement. From there, we can post out the G-code and take a look at the output. You will notice that we're referencing the Remachining Inspection Plus macros, making the code very easy to read. Now that I have set up a work offset on my part using Cimco Probing, we can get into setting up a remachining operation for in-process inspection. The workflow will be identical for any in-process or post-machining checks. To show this, I can set up a remachining operation for the center bore of this part. I will select on the Cimco Cycle Probing icon, Workpiece Inspection. From here, I can select on the Diameter Inside 4-point cycle. Since my probe is already selected, we can go to our Cycle tab, right-click in the Geometry section, and select on my geometry. I will set the cycle up as a normal probing cycle. However, you will notice that I have an if-then conditions option. Cimco Probing considers the part to be in one of three conditions. It could either be scrap, it needs to be remachined, or it's within tolerance. If the part is scrap, I don't want to continue, but perhaps I want to stop the machine or could do a manual entry. In this case, a manual entry would allow me to put in a custom alarm message that will be displayed for the operator. Remachining will allow me to go back to an operation and can select it from the list. This will rerun that part of the program. With intolerance, we'll then continue on like normal. Down below we have a couple options in order to tell it what tool number we want to update, the tolerance that we're going to use for remachining, when not to update a tool offset. If we are going to update the tool offset, we can tell it how much deviation to do it by, but not to exceed a certain value. This is important because the machine is making these decisions automatically, and if a upper tolerance limit were to be exceeded, the machine will simply alarm out. Once set, I can hit the green check mark, run my probing operation through simulation. From there, I can post out the G-code and take a look at the output. Looking through the code, the first thing I will notice is that I have a restart label ahead of my contour operation. This gives it a location to jump back to in the code in case it needs to be remachined. Down below, you will see my probing operations measuring my inside bore, followed by my FANUC macro B logic in order to determine if we are inside or outside of tolerance. For questions or more information regarding CIMCO Probing, reach out to Prototech or your local CIMCO reseller. Thanks for watching.